Today we're going to talk about how to collect data when doing a scientific experiment. The goal is to learn how to collect both quantitative and qualitative data using some basic lab equipment. First, what is data? Data is information we get from observations. There are two types of data. The first is quantitative data. This is data that can be expressed as a number. We collect quantitative data through measuring or counting. For example, think about a bookcase. I can measure and see that it's 3 feet tall. We can weigh it and see that it's 100 pounds. We can count the number of books on it, and so on. In each case, I'm reporting a piece of quantitative data because I'm reporting a number. The second type of data is qualitative data. This is data that cannot be expressed as a number. Instead, we use descriptions or characteristics. For example, think about the same bookcase. I can tell you that it's made of wood, that it was made in Italy, that it's brown, that it smells like oak, and that it's smooth. These are not numbers, but rather descriptions of various traits the bookcase has. So these are examples of qualitative data. Now, let's talk more specifically about some basic types of quantitative data. There are 5 types. The first is mass. Mass can be measured using a triple beam balance or digital scale. In the image here, I'm trying to find the mass of a cube using a triple beam balance. You'll notice that there are 3 scales or beams there at the bottom of the screen. The middle one goes in increments of 100 grams. The top goes in increments of 10 grams, and the bottom goes in increments of 1 gram. When trying to find the mass of a cube, we start with the middle scale. You slide the weight to the right until you pass the tick mark that you see in the bottom right corner of that image. And then you back the slider up one place from there on the scale. So I slid it all the way to 500 grams. It went past the line, so I slid it back to 400 grams. Then you go to the top beam. Slide the weight to the right until you pass that tick mark. Back the slider up one place from there. Then go to the bottom beam. Slide the weight to the right until you land precisely on that tick mark. Once you've done that, you just add the 3 numbers up, and that tells you the mass of the cube. The middle scale shows 400 grams, the top scale shows 20 grams, and the bottom scale shows exactly 9.3 grams. Now, in case you're wondering, that 0.3 comes from those very, very small lines on the scale. Each one of those counts as a 0.1. So since I'm 3 lines past the 9 on that bottom scale, that's how I got 9.3. So add up the 3 numbers, 400 plus 20 plus 9.3 makes a total of 429.3 grams. That's the mass of this cube. Now it's your turn to practice reading a triple beam balance. Based on the location of the weights on the 3 scales, what is the mass of the object you're measuring? Pause the video here to do the calculation. Okay, the total should have been 272.1 grams. How did we get that? Read the middle scale first. It says 200 grams. Read the top scale second. It says 70 grams. Read the bottom scale last. It says 2.1 grams. Again, the 0.1 is because you're one of those small lines past the number 2. So 200 plus 70 plus 2.1 equals 272.1 grams total. You can also use a digital scale to measure mass, and this is a lot easier than the triple beam balance, and it works a lot better for small objects. So in this image, I am measuring the mass of some sugar. You set a weigh boat, it kind of looks like a plate or cup on the scale, and you tare the scale. The tare button is there in red. That just sets the scale to 0. The purpose of the weigh boat is just to hold the sugar. We set the scale to 0 after the weigh boat was on the scale because we don't want to include the mass of the weigh boat itself. We only want the mass of the sugar. So we then pour in the sugar, and when we're finished pouring, the number on the scale is the mass we record. In this case, it's 50 grams. Okay, the next common type of quantitative data is volume. Volume is measured using a graduated cylinder. You just fill the graduated cylinder with liquid, which in this case is water that we've get from the sink. And after you finish pouring, you find the curve that you see at the top of the liquid. And this curve is called the meniscus. You want to get eye level with the bottom of the curve. Then you can determine the value of each tick mark on the graduated cylinder. In this case, each tick mark on the graduated cylinder is 0.5 milliliters. So you count up from 10 on the graduated cylinder to the bottom of that curve where I've got that red dashed line. As you count up, you're moving in increments of 0.5 milliliters. So you should see that the imaginary line is at 13. The volume of the liquid in this graduated cylinder is 13 milliliters. Let's practice reading volume using a graduated cylinder. When you pause the video in just a second, you need to first determine the value of each tick mark on the graduated cylinder, then find the bottom of the curve. Draw an imaginary line there and determine the volume at that point. Okay, pause the video now to do that. Okay, so each tick mark is 0.1, and as you count up from the 6 to the bottom of the curve, which I've marked with that red line, you'll see that you've counted 3 tick marks up. So that means the volume of liquid in this graduated cylinder is 6.3 milliliters. You can also find the volume of other things besides a liquid. You can do that by using a method called volume displacement. As long as the object can fit inside the graduated cylinder and the object sinks to the bottom, you can use this method. First, you need to fill the graduated cylinder with water and measure that initial volume. Based on the picture, our initial volume is 50 milliliters. Then you're going to drop the object into the graduated cylinder. Now you determine the final volume. Based on the picture, the final volume is 60 milliliters. To determine the volume of the object you dropped in the graduated cylinder, just do this. You do the final minus the initial volume. So in this case, it was 60 minus 50, and that comes out to be 10 milliliters. So when I ask what's the volume of the object, when we're talking about solid objects like this, we don't use the unit milliliters. Instead, we use the unit cubic centimeters. The number, this is the important part, the number stays the same. So it's final minus initial, whatever number you got, that stays the same. The only thing that changes is the units at the end. Instead of saying it in milliliters, we say it in cubic centimeters like I've shown here. Now it's your turn to practice volume displacement. The image on the left shows your initial volume. The image on the right shows your final volume. Pause the video and do the calculation to determine the volume of that black cube. Okay, first we have to determine the value of each tick mark on this graduated cylinder. Each mark in this case represents 1 milliliter. So in the image on the left, the bottom of the curve is at approximately 12 milliliters. It's 2 marks up from the 10. And in the image on the right, the bottom of the curve is at approximately 20 milliliters. So you take final minus initial, which would be 20 minus 12, and that's going to be equal to 8 milliliters. But remember, since this black cube is a solid object, we don't use the units milliliters. Instead, keep the same number, 8, but just change the unit from milliliters to cubic centimeters. A third type of quantitative data is length. In our labs, length will be measured using a metric ruler. On the metric ruler in this image, you'll see the letters cm, and that just stands for centimeters. And there are a total of 10 centimeters on this ruler. Each little tick mark between the numbers represents 0.1 centimeters. So if I asked you to measure the length of this pencil, you would first place the edge of the pencil where the eraser's at on the 0 centimeter mark, which is at the edge of the ruler. And then the tip of the pencil where the lead is at, you can see, as I've zoomed in here so you can see more clearly, it's the tip of that pencil is between 8 and 9 centimeters, but we want to know exactly what it is. So you count the ticks, and remember each tick is 0.1. So if you've done it correctly, you will see that it's 8.8 centimeters. Now it's your turn to practice reading a metric ruler. Determine the length of this paper clip. Just pause the video now to do it. Okay, so we placed one end of the paper clip on 0 centimeters, and the other end of the paper clip ends on the 4th tick mark past the 4. So that means this paper clip is 4.4 centimeters long. A fourth type of quantitative data is temperature. Temperature is measured using a thermometer. The C on thermometers stands for the unit Celsius, and the F on thermometers stands for the unit Fahrenheit. In our labs, I will ask you to record in Celsius. If we zoom in here, we can figure out the value of each tick mark. There are 4 tick marks between the 30 and 40, which tells me each tick mark represents 2 degrees Celsius. So we draw an imaginary line, and you see that the temperature is about halfway between 32 and 34 degrees. So what's in between 32 and 34? The number 33. So the temperature here is 33 degrees Celsius. Now it's your turn to practice reading a thermometer. Pause the video and determine the temperature in degrees Celsius. Okay, there are 4 tick marks between the 20 and 30 degree marks. That means each tick mark represents 2 degrees Celsius. So draw an imaginary line, and you'll see that the temperature is between 22 and 24. What number is between 22 and 24? 23. So the temperature is approximately 23 degrees Celsius. The final type of quantitative data we'll discuss is time. Often during experiments, you need to measure how much time has passed, and you can do this using a clock, a stopwatch, or even a calendar in cases where a lot of time has passed. You've probably used these before, so we won't practice measuring time in this video. And with that said, now you should know 2 types of data that can be collected in an experiment: quantitative data and qualitative data. And you should now know how to collect 5 common types of quantitative data using some basic lab equipment.